Welcome back, everybody. In this video, we're going to go over addition and subtraction of integers. So the first way that we'll take a look at it is by drawing numbers on a number line, and then we'll see a better way of doing it. So first of all, how you can add numbers on a number line. If we want to add, for example, -2 plus -3, we would begin at 0, and then to put -2 on, we could represent that by 2 hops to the left. That would put us at -2. Okay, and then to add on -3, we would go 1, 2, 3 more hops to the left, leaving us at -5, so that the answer is -5. Okay, and so that's that. If we wanted to add -8 and 3, again, we could start at 0, and we would need to put on enough for -8. Some people don't like to draw in all the hops. That's okay too. You could just start at -8. Now, to represent the addition of +3, we would have to go back towards 0 for this. So we'll be going to the right, and that would leave us at -5. So the answer on this one would be -5. So you can probably tell by the fact that I really sped through that I don't really care for doing this on a number line. I think it's time consuming and error prone, because you have to sit and try to remember, okay, which way should I go? And every time you need to do one of these, you need to have or make a number line. So we'll see a better way of doing it. Just to get the idea, sometimes it can be useful, and some people like to draw the number line though. So I did want to show you 2 examples. Okay, so in order to do the kind of other way, we'll need to look at something called absolute value, which has other uses in its own right, but we'll take a look at absolute value. So the point for absolute value is sometimes we're interested not exactly in what a number is, but just how far the number is from 0 on the number line. So for example, if you have the number 4, it's 4 units away from 0. If you have the number -3, it's 3 units away from 0, right? So how you would express this is through a pair of vertical bars. We could write vertical bars with a -3 inside, and the answer or value of that is going to be +3. That expresses the fact that -3 is 3 units away from 0 on the number line. 4 is 4 units away from 0 on the number line. A couple of other examples. If you wanted to know, well, how far is 6 from 0 on the number line? It's 6 units away. -116, 116 units away. So after a couple of examples, you'll get the idea that if it's a positive number, like the absolute value of 25, you're just going to get that same number back again, and you're right. If it's a negative number, like the absolute value of -32, that'll be +32. That's going to just be its opposite. So just kind of turn the number positive. Some of my students like to say you throw away the minus sign. All of those are kind of legitimate ways of thinking about it. So we want to see some examples next. All right, so let's try some examples. The absolute value of -23 will be 23. The absolute value of 31 will be 31. For the next one, we have the absolute value of 5 and then a minus sign in front of it. So just doing the absolute value part first will give us 5. And then don't forget to carry over that minus sign. We get -5. If you were thinking, well, I thought you said that absolute values were always positive or not negative, that's true. But notice on this one that in front of the absolute value sign, we did have a negative. The value of the absolute value part is non-negative. This one just had the minus sign in front of it as well. An evaluate question, if p is -14, we want the opposite of the absolute value of p. So let's see that. So we'll replace the p with its value, which is -14, and then compute. The absolute value of -14 will be 14. And then, as you can see, I'd carried over that minus sign that was in front, giving us in all -14. The absolute value of 0 will be 0. It's not undefined or anything. It's legitimate to ask how far is 0 from itself. and it's 0 units away. Okay, so this has been a quick look at absolute value. Remember that the absolute value of any number is going to be greater than or equal to 0. Okay, absolute value measures the distance of a number from 0, and distance is always positive or non-negative. If someone is standing 6 feet in front of you, they're 6 feet away. If someone is standing 6 feet behind you, they're still 6 feet away. You would never say that they're negative 6 feet in front of you if they're behind you, right? Nobody does that, right? Absolute value is always greater than or equal to 0. Okay, so that's useful in its own right, but also it will help us right here when we start actually working on addition. So we're going to divide addition into cases, meaning depending on what the problem looks like or the calculation looks like, that will help us decide what to do. So for addition, where the add ends, that's the numbers being added, have the same sign. Here's what you do. 2 steps. Nice and easy. You add the absolute values of the numbers, then the sum has the same sign as the numbers you're adding up. So 14 plus 10, just as you've always done it, just keep doing that, okay? Unless it was on a calculator. So 14 plus 10, the absolute value of 14 is 14. The absolute value of 10 is 10. Okay, that was kind of not essential. So then add the 2 numbers up. 14 plus 10 is 24. And then the sum has the same sign as the add-ins. We're adding together 2 positive numbers. We should get a positive sum. And that's it. So in short, for this one, if you're adding 2 positive numbers, just do it the way you always have. Okay? Slightly more interesting is if you're adding together 2 negative numbers. Negative 5 and negative 7. The absolute value of negative 7 is 7. And then the absolute value of negative 5 is going to be 5. So step 1 there says add the absolute values of the numbers. So 7 plus 5 makes 12. Okay, then the sum has the same sign as the numbers we're adding. We were adding 2 negative numbers, and so we'll get a negative sum. The answer there, negative 12. Okay. A little bit more on the same topic. If we're adding together numbers that have the same sign, use the putting together idea of addition along with something real and tangible like money or weight, and then your answer should make sense. Okay, so suppose that you work 18 hours this week and 14 hours next week. How many hours is that in all? Well, we have 18 hours one week and 14 hours the next week. I think anybody's going to interpret these as positive numbers. So that's 28 plus 4, or 32 hours. So that's not bad at all. Okay, for the next part, it says Bob loses 3 pounds this month and 2 pounds next month. We want to know how much he lost in all. So here we can represent the loss of weight as negative numbers. So there's a 3-pound loss in the 1 month, and then a 2-pound loss in the next month. Well, here, the absolute value of negative 3 is going to be 3. The absolute value of negative 2 is going to be 2. We'll add 3 and 2 together to give 5. And then we're adding together 2 numbers that are negative, and so we should get a negative sum. And thinking this through with everyday life experience, if somebody lost 3 pounds and lost another 2 pounds, that would be a total loss of 5 pounds. And so here we're representing losses in weight by negative values, and so that makes sense in the Okay, a couple of additional examples, and then we'll see what it's like if the signs are different. Okay, 12 plus 17, that's going to be 29. We're just adding together positive numbers the way that we always have. Okay, at this point, you can pause the video and try the last 3, and then restart the video to see how you did. Okay, so now for negative 3 plus negative 18, the absolute value of negative 3 is going to be 3. The absolute value of negative 18 is 18. 3 plus 18 is 21. And then we were adding together negative numbers, so get a final answer of negative 21. Okay, and again, you can try on something everyday life to help you. Let's say that you lost $3 at the casino, and then the next day you lost $18 at the casino. Altogether, you've lost $21 at the casino. Okay, it's a contrived example, but it works. Okay, 8 plus 11 is 19. And then negative 43 plus negative 12, we're adding together negative numbers. We'll get a negative answer. 43 plus 12 is 55. So we'll get in all negative 55. Okay. You'll notice that when we add together negative numbers, we get a negative sum. So keep in mind then that adding doesn't necessarily make things bigger. If you're adding together negative numbers, in fact, it makes things smaller. Okay, so now how do you do it, or what do you do if the add-ins have different signs? So this part, people can find it a little bit trickier, so you want to be careful, but still it's only 2 steps. So when you're adding together add-ins that have different signs, then you subtract actually the smaller absolute value from the larger. So let's try that. For negative 11 plus 18, the absolute value of negative 11 is 11. The absolute value of 18 is going to be 18. Okay, and then 18 plus, or 18 minus 11 is 7. Okay, and then that's the end of step 1. Step 2, the sign of the sum is the same as the add-end with the larger absolute value. Here, the add-end with the larger absolute value is 18, which is positive. So our final answer will be positive. Let me say that again. We had negative 11, we had 18. The one with the bigger absolute value is 18. 18 was positive, so our final answer is positive. Okay, 8 plus negative 13. The absolute value of 8 is going to be 8. The absolute value of negative 13 is going to be 13. Okay, so subtract the absolute values. 13 minus 8 is 5. Okay, that's the end of step 1. Step 2, the sign of the sum is the same as the add-in with the larger absolute value. Here, the larger absolute value is going to be negative 13. So the final answer will be negative 5. What people find confusing about this is the fact that in order to answer this addition problem, it's an addition problem, right? In order to answer the addition problem, we end up doing a subtraction. The reason we end up doing a subtraction here is because we're comparing the relative sizes of the negative piece and the positive piece. And as you recall, one of the meanings for subtraction, or one of the uses for subtraction, is when we're comparing two values. Okay, we'll come back to that after we've practiced following the steps a few more times. Okay, so here we've got a mixture of different problems. 17 plus 3 will be 20. Okay, there we're just adding together two numbers, the same sign, both positive. Negative 20 plus 8, there they differ in sign. So we're going to need to subtract the absolute values. Absolute value of 20 is 20, and the absolute value of 8 is 8. 20 minus 8 is 12. Here, the one with the bigger absolute value is negative, so the overall sum is negative. Okay, back to the easier case in a way. Negative 12 plus negative 4 will be negative 16. Just adding together two negative numbers. 15 plus negative 3. There, the two absolute values are 15 and 3. We subtract them, getting 12. The one with the bigger absolute value is positive, so the final answer is positive. 11 plus 14 is 25. Negative 11 plus negative 14, negative 25. The ones where the sign's the same, I think, are a little bit easier. Negative 17 plus 3. Here, the absolute value of negative 17 is 17. And the absolute value of 3 is 3. 17 minus 3 is 14. And then, to get the sign of the sum, the one with the bigger absolute. Sorry, Zoom crashed on me. Okay, so I don't know how far back that stopped, so let me repeat the last one. Negative 17 plus 3 was negative 14. The absolute value of negative 17 was 17. The absolute value of 3 is 3. 17 minus 3 is 14. 17 plus negative 3, the absolute value of 17 is 17. The absolute value of negative 3 is 3. 17 minus 3, 14. What's different this time is that the number with the bigger absolute value is the positive one, and so our final answer is positive 14. The graphic shown here to the right can kind of help you, potentially, help you remember how this goes. Taking the first two rows, if we add together two smaller positive numbers, we get a bigger positive number. If we add together two negative numbers, then we get a number that is more negative. Okay, then the ones that are a little bit trickier, if we have a bigger positive number, when I say bigger here, I mean in terms of absolute value. If we have a bigger positive number and a smaller negative number, adding them together, we'll get an answer that's positive, but less so. Adding a small positive and a big negative, we'll end up with a number that's negative, but less negative. Okay? All right, a little more. All right, so I wanted to go into a little more detail about why this works the way that it does, just to make sure that we get this right all the time. So another way of representing positive and negative numbers is through the use of, some people use colored chips or discs, or we could just use plus and minus signs. I'm going to use a plus sign to represent a positive 1 for this next few examples, and we're going to use a dash or minus sign to represent a negative 1. Okay, and then the kind of key fact that we'll need throughout these examples is that if we are to combine a plus and a minus together, that's going to equal 0. That is a fundamental fact, is that positive 1 plus negative 1 should equal 0. And this is going to fit our intuition if we think about things like if you found $1 on the ground and then it fell out of your pocket, then you're even, you're back to 0 again. If you take one step forward and then one step back, you're back to where you started. If you gain a pound and then lose a pound, you're again back to where you started. An addition of 1 and a subtraction of 1 should leave you with nothing. So a plus and a minus together are going to add up to 0. Okay, so that said, let's try some of these examples. And I'm using basically 5 and 2s for all of this, and then just varying the pattern of minus signs. Okay, so 5 plus 2, this would be positive 5. We're going to add to it another positive 2. How many plus signs do you see? You should see 7 plus signs, so that's positive 7. Okay, easy enough. Negative 5 plus negative 2. There's 5 negatives and 2 more negatives. That makes a total of 7 negatives. Okay, negative 5 plus positive 2 would be 1, 2, 3, 4, 5 negatives and 2 positives. Here you can see that there are 2 plus minus pairs that are going to add up to 0. What's left over is negative, which is why the final answer is negative. And to figure out how much is left over, you subtract, right? 5 minus signs and 2 plus signs. You're going to know that there are 3 extra minus signs. And that's why you end up with negative 3 for the final answer. Okay, for 5 plus negative 2, here we'll have 5 plus signs and 2 minus signs. And then again, we'll have 2 plus minus pairs that add up to 0. This time, there are, I have one too many plus signs. Sorry. This time there are 3 leftover plus signs. So we have a positive 3 for our final answer. Okay, just to make sure that we got that okay, let's try this kind of a mental example. So let's say that we're going to do 75 plus negative 8. Okay, I'm pretty sure you don't want me to draw out 75 plus signs and 8 minus signs, right? But let's say that I did a whole bunch of plus signs, just a ton of plus signs, 75 of them, and then 8 minus signs. Okay, so if I did that and then started pairing off pluses and minuses, do you think that I would have leftover pluses or minuses? Clearly, I'm going to have a bunch of pluses left over. So our final answer is going to be positive. And then to figure out how many there are left over, 8 of the 75 pluses would get paired with the 8 negatives. And so that would leave us with 67 pluses. Another way to think of that would be to say, well, 75 is the same as 67 plus 8. Right? 67 plus 8 is 75. And then 8 plus negative 8 is going to add up to 0. And so that would leave you with positive 67. One more. Let's say that you had negative 32 plus 9. Okay, and here we would have 32 minus signs. Okay, and then 9 plus signs. So more minus signs, right? We'd be left with minus signs in the end. And then to figure out how many minus signs extra we'd have to subtract, right? So we would 32 minus 9, and that would leave you with 23. Okay, so you should have negative 23 in the end. Okay. All right, so you could also look at this as negative 23 plus negative 9 plus another negative 9. And then that plus negative 9 and plus positive 9, again, add up to 0. There we go. Leaving you with finally the negative 23. If you were okay with the description written out in words, that's good. If you like the idea of the plus and minus signs, that's good. However works for you, it works. Okay, so as long as you can find a meaning for this that makes sense to you, that is okay. All right, so we just have a couple more examples in this next one. We have 3 addends. We'll just work from left to right. 5 plus negative 7. Here we're adding together 2 numbers that differ in sign, and so we'll subtract their absolute values, and that will give us negative 2. That was 2. And so negative 2 plus 3 will give us positive 1. Okay, in the next example, we are evaluating 3x plus y when x is 2 and y is negative 8. So we'll replace the x by positive 2, sorry, then the y by negative 8. Okay, and then 3 times 2 is 6, and 6 plus negative 8, is it 2 or negative 2? Well, I know 6 and 8, the absolute value of 6 is 6, the absolute value of negative 8 is 8, and 8 minus 6 is 2. If, again, I drew out all those plus and minus signs, we'd have extra minuses. So in the end, it is negative 2. All right, that takes us to the end of this first part that is about addition of integers. In the next part, we'll finish up this section by doing subtraction of integers. In the meantime, let me know if you have any questions, and then have a great day.